This is the calorimetry lab, and if you can get this lab out, and this is the setup. You'll notice that this little setup with the ring stand and the thermometer and the test tube, and we have our food sample and our cork, looks very similar to what we have over here. So I want to walk through the introduction and the procedure for this, and then we'll go ahead and we'll begin. So this is in the reading. You can go ahead and read along with me as you do this. By burning pieces of food, the chemical energy that's stored in the molecular bonds, these are the carbon-carbon bonds primarily of the food, is released as heat and light. This is like the carbon-carbon bonds that get ripped apart when it goes into your cells, into your mitochondria, and all the carbon-carbon bonds are ripped apart, and that gets converted into energy. So the same thing is happening here, except we're releasing it very, very quickly. This heat can be measured in units called calories. A calorie is the amount of heat energy required to increase the temperature of 1 gram of water by 1 degree. So this is what we're doing. We're going to be lighting our food, and this is a nut, and it is a fat. We'll get back to that in a minute. So what it's going to do is when we burn those fats, it's going to heat the water above it. And by the amount of water, or by the amount of heat, the temperature increase that occurs in the water, we could determine the amount of heat that was released by the nut. So this is how it's calculated. We're trying to see how much the temperature of the water raises, and we know the specific heat of the water. Therefore, by the temperature change of the water, we can calculate how much heat and how many calories went into heating that water. So a calorie is the amount of heat required to increase the temperature of 1 gram of water by 1 degree Celsius. This process is the basis of a technique called calorimetry. The more calories a food contains, the more heat is given off when burned. Foods high in calories will release large amounts of energy. 1 gram of protein will release far fewer calories than 1 gram of fat. So we're going to be only taking a look at this one. I usually use Cheetos, but I don't have any Cheetos, and so I'm going to be using this nut. This reminds me, every time I do this lab, I was living in a big apartment complex with a bunch of friends, and this is during my graduate school career. And one of my friends, who was a previous roommate of mine, his wife comes over and says, we don't have any candles for his birthday cake because it was his 30th birthday or something like that. And so I thought, I have an idea. And I said, do you have any almonds? And she said, yes. And so what I did is I sliced the almonds very, very thin, knowing that almonds are just like this nut here and contain lots of oils in them. Again, think of peanuts. If you squeeze a peanut, you're going to get peanut oil and peanut butter, and that oil can actually burn. And that's what we did. We sliced the almonds very, very thinly. We topped them on top of the cake. I think there may have been 30 pieces of them. And we lit them very, very quickly, and we had 30 little almond slices inside the cake that was burning. So, and you can eat them afterwards as well because they're nice and toasted. So that is the story of the oils that are inside this. So we're going to be going through the process now. We have our setup, as you can see, and place 50 milliliters of water. I already did that. I measured it to 50. So inside here is the 50 milliliters of water because we need to know what the mass of that water is, and we'll get to that later. So we have that attached to a test tube clamp to the ring stand, and we set up the Lab Pro device. Here's the Lab Pro device. Again, here's the thermometer. The Lab Pro is behind the computer. Everything's working. We obtain a small piece of aluminum foil. Here's the piece of aluminum foil. We place it on top of a cork to catch any pieces of burned food that might fall down during the experiment. We poked a needle, and the cork and the food is sitting right there. We're going to weigh the entire cork aluminum foil complex. I already weighed that for you, and I'll give that data to you in part 2 of this video when we do the mathematical analysis. So we place the food piece, okay, and we place the apparatus beneath the test tube, And we lowered the clamp so it's about 1 centimeter above the food sample. Okay. What we're going to do now is we're going to remove the apparatus. We're going to light the sample with the lighter, and immediately we're going to place it under, and we're going to press collect. So I'm going to press collect. I'm going to light the sample, and the heat's going to go up. Now, what might happen is this